Okay, this is lesson 5, Hungarian Algorithm, but now we're going to be looking at maximizing. Okay, so this should be pretty quick, this lesson, because there's only one extra step that we need to add in at the start. Okay, let's get started. So today is all about maximizing. All right, so we'll talk about this extra step that we need to add in. Okay, the Hungarian algorithm is designed, like I said, to minimize. All right, so however, this time we want to be able to use it to maximize. Okay, so as I suggest, it is very, very simple for us to be able to do that. Okay. Let's get started. So here is our task here. Okay, so for example, for a store owner, all right, you probably want to try and maximize each of these 3 people to the store which they're going to be working at. So as opposed to minimizing, we want to in fact maximize this case. All right, so step number 1 we're going to do is, as we did previously, represent it as a matrix like so. Once you've done that, the only additional step that we're going to add in order to maximize or use this Hungarian algorithm to maximize is you're going to select the largest number in the whole matrix. In this case, it's 20, which is right in the middle. Okay, doesn't matter where it's located, but in this case, it's 20. What you're then going to do is subtract every single value in the matrix from that largest value, in this case being 20. All right, and what we're going to see is a new matrix designed. So subtracting every single value in its same location from 20, right, we end up with 8, 3, 9, 9, 0, 13, 12, 4, and 15. Okay? That's the only extra step you need to add into this Hungarian algorithm to maximize. Everything else from here is exactly the same. Nothing changes to what we've done previously. So the rest of this video is basically a bit of a review on the minimizing. Okay, you can watch through as we flick through this in order to allocate the tasks to each of the different people. All right, but effectively, like I've just said, that is the only extra step. Okay, let's go. As we've done previously, subtract each of the rows, identifying the smallest number. There they are. And you end up with these values here. Once you've done that, it's going through each of the columns, as we've done previously, identify them, subtract them from each of the columns, and you end up with these numbers here. Right, once you've done this, use the fewest number of lines, okay, in order to cross off the zeros, and it's going to be a nice easy one, which is going to be straight across there and straight down there. Now, it does not match the number of lines, which is 2, to the number of rows or columns which we've got, which is 3. So therefore, we need to repeat the process, okay? So anything which only has 1 line through it doesn't change, which are those ones. The smallest uncovered value is 3, right, down in the bottom left. So we need to subtract that from all of the uncovered values, which are those 4 there. And then anything which is covered up by 2 lines, we're going to add that value to it, which is why that 3 is being generated there. Okay, now from here, redesign your lines. There we go, like so. That is in the fewest number, and we have drawn 3. Therefore, we can now allocate each of the tasks. So in allocating each of the tasks, right, it's a little bit tricky, this one. Okay. There is my allocation there. That is the only possible way of doing this. Okay. And then corresponding those ones back to the tasks, 8, 20, and 11. Okay, adding them together, and we end up with 39. Remember, read the question. Always come back to this, which is going to be in thousands of dollars. Okay, so therefore, answer the question is going to be $39,000. All right, at the end, please make sure you go back and read the question, because lots of the time they are in thousands of dollars or hundreds of dollars or hours or minutes or something like that. So make sure you go back and read the question there. All right, perfect. Here's another one. Once again, we're trying to maximize, okay, 4 machines and 4 people. It would be ideal for these people to be able to maximize their output effectively. Okay, and how efficient they are. Number of units each worker can produce in a day, etc. So we want to maximize this. Once again, we want to put it as a matrix, like so. Identify the smallest number, the largest number, okay, and we want to subtract every single number from that. So our largest number in the whole matrix is 30, and in doing that, we're going to subtract every number from that. Okay. Generally speaking, it's quite good because it makes the numbers a bit smaller. Alright. Once you've done that, subtract rows, subtract columns. So subtracting rows through here, like so. Once we've done that, we're now going to subtract the columns. Okay, 0 the first, 0 the second, 0 the third, and 2 in the fourth. So that's nice because the first 3 columns will stay the same. And the last column is subtracting 2 from each of those values in the last column. Okay, now once we've done that, we're now trying to cover up all of the zeros. 2 zeros in the first row, so that's a good idea to cover that one up. 2 zeros in the second column, so a good idea to cover that one up. And we've got a 0 here. 4 allocations, but only 3 lines, so therefore we need to repeat that process. All of the numbers covered up by a single line will stay the same. Identify the smallest number, which is uncovered, which is 2. Subtract that from all the uncovered ones, like so. Anything which is covered up by 2 lines, in other words, the top 2, you're going to add those 2 numbers in and repeat the process. 1, 2, 3, 4. Perfect. Right. So, this is the copy of what we've got down in the bottom left. We now need to allocate each of these. 1 0 in each row and 1 0 in each column. Once you've done that, correspond those back to where the locations are, like so. Right, make the allocation. So Asher is 3, Macy is 2, Tana is 4, and Karis is 1. Add them up, and you end up with 1/4 units. Making sure you read the question to make sure it's not in thousands of units or anything like that. And that's it. Okay? Alright, good luck. Give the questions a go.